Welcome! Have you ever wondered why objects aren't constantly emitting or absorbing light? This is a fascinating question that takes us into the world of quantum physics and energy states. Let's start by understanding what's happening at the atomic level. Atoms consist of a nucleus surrounded by electrons. These electrons orbit the nucleus at specific energy levels. These energy levels can be visualized as shells or orbits around the nucleus. In reality, the electrons exist in quantum states with discrete energy levels, which we can represent as horizontal lines, with higher lines representing higher energy states. Now, let's discuss emission. Emission of light occurs when an electron drops from a higher energy level to a lower one. When this happens, the electron releases energy in the form of a photon, a packet of light. But here's the key point. If all electrons are already in their lowest possible energy state, what we call the ground state, there's nowhere for them to drop to, so they can't emit any more light. For emission to happen, electrons first need to be excited to higher energy levels. This excitation requires an input of energy from heat, electricity, or even other light. Now, let's talk about absorption. Absorption happens when an electron captures a photon of light and uses that energy to jump to a higher energy level. But there's a catch. The photon must have exactly the right amount of energy to match the gap between the electron's current level and a higher level. If the energy doesn't match, the photon will simply pass by without being absorbed. It's like trying to jump upstairs. You need just the right amount of energy to reach the next step. Too little, and you won't make it. Too much, and you'll overshoot. Also, if all electrons are already in higher energy states, there's nowhere for them to go, and they can't absorb more light of that specific energy. At thermal equilibrium, when the body is at a constant temperature, emission and absorption reach a balance. This doesn't mean all atoms are emitting or absorbing all the time. It means that across the entire material, the rates of emission and absorption are equal. Some atoms will be emitting, some absorbing, and many doing neither at any given moment. It's a statistical process that depends on the available energy states and photons. Here's a helpful analogy. Think of electrons like people on a staircase. Emission is like someone going down the stairs. But they can only go down if they're already up. If everyone is already at the bottom, no one can go down anymore. Absorption is like going up the stairs. But they need the right amount of energy to climb exactly one step. And if all the higher steps are already full of people, no one else can go up. To summarize, objects don't emit light all the time because their electrons can't drop to lower energy levels if they're already at the lowest level. And they don't absorb light all the time because either there aren't photons with the right energy available or the electrons are already in higher states with nowhere to go. Next time you see an object that's not glowing or that appears colored because it absorbs certain wavelengths, remember, it's all about these energy transitions at the atomic level. Thank you for watching.